Hello and welcome back to another video. In this problem, we're asked to prove without graphing that the graph of the function has at least two x-intercepts in the specified interval. So we have y is equal to sine of x cubed over the interval from 1 to 2. So what we want here is that this function between 1 and 2 crosses the x-axis twice. And we're going to use the intermediate value theorem. So if we're looking at this x-intercept in particular, we can see that on one end, the values are positive, and on one end, they're negative, right? If we're looking from one direction from the root and in the other direction. And so in order to find what the roots of this function are, we don't actually have to solve the equation. We just have to find a value where it's positive and then negative, or like vice versa, and then we know there's a root in between. And so if we're looking at the interval from 1 to 2, we can take y is equal to sine of 1 cubed, and y is equal to sine of 2 cubed. And all you have to do is plug this into your calculator, and you'll get that this is equal to approximately 0.84, and this is equal to 0.989. And so at one end of the spectrum, it's positive, and at the other, it's positive, which is actually a good thing, right? Normally for the intermediate value theorem, you'd want one of them to be negative, one of them to be positive. But here, since we have there's two x-intercepts, we want it to have start positive, dip down into negative, and then go back up to positive before we hit the end of the interval. So let's just find a point in between. If we do y is equal to sine of 1.5 cubed, then that is equal to negative 0.23. So if we look at this on a number line, we have 1, 2, and 1.5. These values of y are positive, negative, and positive. This is a trigonometric function. Therefore, by theorem 7, we can say that it is continuous over its domain, which in this case for sine is all real numbers. And therefore, by the intermediate value theorem, since f of 1 is greater than 0 and f of 1.5 is less than 0, there exists a root on the interval from 1 to 1.5. And since f of 2 is greater than 0 and f of 1.5 is less than 0, the same is true for the interval from 1.5 to 2. Therefore, on the overall interval, there are two roots. Slash x-intercepts is what this problem is calling them. We can say this by the fact that this is a continuous function, and we can use the intermediate value theorem.